Good afternoon, I'm Ben Lewis, and this is my presentation on simulating gravitational interactions for Lab 3. So the purpose of this lab is split into two parts. Part 1 was to determine the mass of a black hole given the interaction with a star, and then Part 2 was to place a craft in a stable orbit within a system, or just make a cool pattern. For this, we assume FNet to be a combination of gravitational forces, since we're in space and there's really nothing else that could be happening. And we assume certain gravitational forces to be negligible compared to others. So, like the star's force on the black hole, for instance, is negligible compared to the black hole on the star. And then, obviously, gravitational formulas, position update, velocity update, and our parallel and perpendicular equations. So part 1, I used my email as a create C for the initial interactions. From there, determined the initial and final momentum, set FNet to be equal to the change in momentum over delta t, found the parallel and perpendicular forces, calculated the mass of the black hole from the gravitational formula and FNet, and then drew arrows from those to show magnitudes of forces, as you saw with the initial preview. For the second bit, in the loop, determine the distance vectors from the planet to moon, planet to ship, and the moon to ship. Then using each distance vector and the given masses and the gravity formula for universal gravitation, determined FGrav for the planets on moon, ship on moon, planet on ship, and moon on ship. Then calculated FNet for the moon and FNet for the ship by adding, and then use the resultant force, wrote velocity and position update expressions for the moon and the ship. So both examples follow Newtonian principles of gravitation. I determined the mass of the black hole to be around 1.3 times 10 to the 34th kilograms. And after giving the ship a bit of starting altitude, just to make the thing easier, I guess, TA said it was fine, found a stable orbit with an x velocity of 13,000 meters per second and a y of 24,000 per second. So the what if was if we combine both systems into a single simulation, you would need a lot more code to calculate the FNet. You would have to write and calculate position vectors for each one. Now you could leave some out simply because, as stated before, you can consider some negligible, as the gravitational forces of the black hole and star would dominate those interactions for the most part, and it'd just be a lot of code. Another thing was, what was the relation between FNet components and momentum? Parallel force components influence the magnitude of momentum. Perpendicular forces influence the direction of momentum. That's just a fundamental principle. And thank you for watching.